All right, let's talk about cracking the code on something that, let's be honest, can look a little intimidating at first. Simplifying radical expressions. We're going to completely demystify these tricky roots and show you how to make them way easier to handle.
So here's our game plan. We'll kick things off with a classic math puzzle. Then I'll give you the secret key to solve it. We'll walk through some examples step by step, point out a few common traps to watch out for, and wrap up by showing you why this skill really matters.
Okay, let's just dive right in with a problem that you've probably seen 100 times in your algebra homework. So you get this question. Simplify the square root of 72. Now, you know the square root of 36 is 6, right? And the square root of 49 is 7. But 72, it's not one of those nice, perfect numbers. So what do? Exactly. It doesn't have a neat and tidy whole number answer. But what if I told you there's a perfect number hiding inside of 72? The whole secret here is learning how to find it and pull it out. So how do we do that? Well, let's talk about the special tool that unlocks this whole puzzle. It's a really important rule called the product property of radicals. This property right here is our golden key. It might look a little fancy, but the idea is actually super simple. It just says that if you have a multiplication problem inside a radical, you're allowed to split it up into two separate radicals that are multiplied together. It lets us break a big, messy problem into smaller, much more manageable pieces.
So here's our strategy from now on. We're going to peek inside the radical and hunt for the biggest perfect square, or cube, or whatever, that divides into it evenly. And once we find that factor, we use our new rule to split the radical in two and simplify.
All right, enough with the theory. Let's actually put this key into action. We'll walk through a few examples, starting with our original problem and then leveling up a bit.
Okay, back to our old friend, the square root of 72. Let's think about our perfect squares. You got 4, 9, 16, 25, 36, and wait a minute. 36 is the largest one that goes into 72. So we rewrite the square root of 72 as the square root of 36 times the square root of 2.
And now for the easy part. We all know the square root of 36 is just 6. The 2, well, it's not a perfect square, so it has to stay inside the radical. And there's our final answer, 6 times the square root of 2. See how much cleaner that looks?
And you know what? This works for any kind of root. Let's try the cube root of 54. This time we need to look for perfect cubes, like 8, 27, 64. Well, turns out the biggest perfect cube that divides into 54 is 27. So we just split it into the cube root of 27 times the cube root of 2.
The cube root of 27 is 3, so the 3 gets to come outside. The poor little 2 is left behind inside the radical. So our final answer is 3 times the cube root of 2. You starting to see the pattern here? It's the same process every time. Okay, deep breath. Let's try one with variables, the square root of 50x to the 5th. Don't panic, we just handle the numbers and the variables as separate little puzzles. For 50, the biggest perfect square is 25. For x to the 5th, the biggest perfect square part is x to the 4th, because it has an even exponent. We just group those perfect parts together.
Now we just simplify what we can. The square root of 25 is 5. The square root of x to the 4th is x squared. Both of those get to escape the radical sign and go outside. What's left inside? That leftover 2 and the single x. And there's our final answer, 5x squared times the square root of 2x. Not so bad, right?
Okay, this next part is super important. To really make sure you've got this down, let's go over a couple of common traps that almost everyone falls into at some point. This is a classic mistake. So with the square root of 72, you might see that 4 goes into it. And that's true. You could split it into the square root of 4 times 18, which gives you 2 times the square root of 18. But you're not done. You'd have to simplify the square root of 18 again. That's why we always hunt for the largest perfect square from the very beginning. It saves you work and makes sure you don't stop halfway.
And here it is, the absolute golden rule. You have to remember it's called the product property. Product means multiplication. You can never, and I mean never, split a radical up over addition or subtraction. The square root of a plus b is just not the same thing as the square root of a plus the square root of b. Don't even think about it.
So after all that, you might be sitting there thinking, okay, cool, but why? Why do we even need to learn this? Well, it's not just a random math puzzle, I promise. It's a critical skill for what's coming next.
To put it simply, simplifying is just step 1. Later on, you're going to need to add, subtract, and multiply radicals. And guess what?
You can't do any of that efficiently unless they're in their simplest form first. Mastering this now is what sets you up for success down the road.
And this isn't just about passing your next math test. This stuff is used all the time in the real world. In fields like engineering, you're constantly dealing with formulas for things like distance or force. And trust me, plugging a clean, simple number like 6 root 2 into a big equation is a whole lot easier and less error-prone than using a clunky number like the square root of 72.
So there you have it. You've now officially cracked the code on simplifying radicals. You hold the key to the next level of algebra. The only question is, now that you know how to break them down, are you ready to start putting them back together?